14:07 local time, 12,000 feet above Kerman Airport, Iran. From the belly of an F/A-18 Super Hornet, call sign Raven 2, a 500-pound GBU 38 JDAM smart bomb is released into the thin air. Usually, this is a weapon of perfect precision, but today, the sky is working against it. The bomb is effectively flying blind. Without GPS to tether it to reality, it must rely on its internal inertial navigation system. But in the world of aerospace physics, INS has a fatal flaw: inertial drift. Every second away from a satellite signal, the bomb's internal sensors guess its position slightly wrong, and those tiny errors compound into a miss. The pilot, Raven 2, is now facing a terrifying mathematical choice. If he stays safe and high at 25,000 feet, the bomb will fall for nearly 60 seconds. By the time it hits the ground, that tiny internal drift will have grown so much that the bomb will miss by 30 meters, hitting nothing but empty sand. But to destroy the Iranian Il-76 transport plane waiting on the runway, he needs to be perfect. He needs to hit within a tiny 5-meter circle. To get that accuracy, Raven 2 makes a gut-wrenching decision. He pushes his jet into a steep, screaming dive toward the Earth, dropping down to only 12,000 feet. By doing this, he cuts the bomb's travel time to just 20 seconds, giving the drift almost no time to mess up the shot. But this move comes at a high price. By flying this low, he is diving straight into the heart of the enemy's trap, putting his life and his $6 million aircraft right in the crosshairs of every anti-aircraft gun in the desert. It is a 2-0-second race where the pilot is gambling everything to make the math work. While the American pilots were focused on their targets, the Iranian defenders were playing a deadly game of hide-and-seek. They were using the Tor M1, a highly mobile surface-to-air missile SAM system, specifically designed to take down fast-moving jets. Usually, these systems give off a radar signal that pilots can detect, but this crew was smarter. They operated under strict emission control, MCON keeping their radar completely off, and used a high-powered electro-optical camera to silently track the Super Hornets. The moment the F/A-18S crossed the 1-2-kilometer line, the trap snapped shut. The Tor M1 radar flared to life for only a fraction of a second, just long enough to guide a missile. Before Raven 2's warning system could even finish its first alarm, an interceptor was already screaming toward him at Mach 2.8. This missile is a masterpiece of violence, capable of pulling 28 Gs of force. To put that in perspective, that is more than 3 times the pressure that would cause a trained fighter pilot to black out instantly. Raven 2's survival instincts took over. He hauled the control stick back, forcing his aircraft into a brutal 6G turn. At the same time, he punched out a cloud of chaff, thousands of tiny aluminum strips designed to create a ghost image on the enemy radar. The missile took the bait. It exploded 100 meters behind the jet, but even a miss at this speed has consequences. This is where the physics of the mission took a turn for the worse. Under the combined extreme aerodynamic stress of the 6G turn and the massive blast overpressure from the missile's explosion, the aircraft was violently slammed. The jet survived, but its most sensitive tool did not. Under the belly of the jet, the AN/ASQ-228 AT FLIR, the $1 million targeting pod, takes the brunt of the blast. While the airframe holds, the physical shockwave causes an alignment shift in the pod's internal gimbals. The delicate mirrors and fiber optic sensors, designed for precision, are now vibrating against their housings. This creates what military experts call degraded operations. The eye of the Super Hornet hasn't gone dark, but it has developed a permanent rhythmic jitter, making a precise laser lock impossible. Inside the cockpit, the crystal-clear imagery Raven 2 relied on is gone, replaced by a rhythmic, violent seizure of pixels. He is now flying at a dangerously low altitude with a failing sensor and no GPS, a state of degraded operations where every second spent trying to stabilize the image is a second spent in the enemy's crosshairs. The mission is no longer about a surgical strike. It's a desperate scramble to find a target with a broken eye. While Raven 2 orbits in a degraded state, struggling to stabilize a shattered optical feed, the concrete apron of Kerman Airport has transformed into a theater of calculated desperation. The Iranians are well aware that in modern SEAD operations, blindness is only temporary. They don't need to win the war. They only need to win the next 180 seconds. At the center of this storm sits the Il-76 Candid, a heavy-lift transport aircraft that serves as the backbone of the IRGC's strategic mobility. Under normal conditions, starting its 4 massive Soloviev D-30KP turbofans is a rhythmic patient process roughly 90 seconds per engine to ensure thermal stability. But the Iranian flight engineer has just discarded the manual. He initiates a combat start procedure, a high-risk maneuver that forces the auxiliary power unit APU to bleed high-pressure air into all 4 starter valves simultaneously. This is a brutal wager against physics. By bypassing safety interlocks, the engines are being choked with fuel and air, creating a massive thermal bloom that would normally melt internal turbine blades. In the logic of the Iranian calculus, the structural lifespan of a multi-million-dollar engine is a cheap price to pay for escape. As the airframe begins to vibrate under the violent awakening of 106,000 pounds of thrust, the ground crews are working with a feverish intensity. They aren't loading standard supplies. Forklifts are frantically shoving long, olive-drab crates into the rear cargo hold. These cases contain ballistic missile optical guidance kits, the brains required to turn Iran's unguided rockets into precision strike weapons. A single Il-76 carries enough kits to outfit an entire missile brigade. If this plane leaves the tarmac, the strategic cost to the coalition will be measured in thousands of lives, not just one aircraft. To protect this exit, the Iranian commander isn't relying on luck. He has deployed several ZU-23 twin-barreled anti-aircraft gun systems at both ends of the runway. These gunners are not aiming for a kill. They are creating a wall of lead, a ballistic barrier designed to keep the Super Hornets at an altitude where their broken cameras cannot resolve a target. The math of the encounter has shifted. Raven 2 is fighting a failing targeting pod, while the Il-76 is fighting the clock. The heavy transport needs 180 seconds to reach rotation speed. The American pilot needs 20 seconds of stability to drop his bomb. It is no longer a battle of technology. It is a race between a screaming engine and a dying sensor. As the 3-minute countdown for the Il-76's departure nears its end, Raven 2 is fighting a losing battle with his own cockpit. The jitter on his display has become a rhythmic seizure, making it impossible for the damaged ATFLR targeting pod to distinguish the cold, dark silhouette of the transport plane from the gray expanse of the concrete apron. But just as the mission reaches the edge of failure, the enemy's aggression provides a lethal solution. Below, the Iranian ZU-23 anti-aircraft gunner, consumed by a deadly enthusiasm, is no longer firing in controlled bursts. He is leaning into the trigger, desperate to keep the American jet away. At a combined rate of 1,600 rounds per minute, the kinetic friction inside the 223mm steel barrels is generating astronomical levels of heat. The outer paint on the barrels melts and vaporizes, leaving the metal glowing a terrifying cherry red. In the physical world, it is an anti-aircraft weapon. In the infrared world, it has just become a thermal lighthouse. Through the jittering feed of the damaged ATFLR, the Il-76 is a ghostly, unstable blur. But just 120 meters away, the Iranian ZU-23 gunner has just made a fatal mistake. By firing continuously, his steel barrels have reached over 600 degrees Celsius. In the infrared spectrum, those barrels are no longer just weapons. They are thermal lighthouses screaming through the electronic noise. Raven 2 realizes he can't lock onto a blur, but he can lock onto a sun. Using his thumb on the stick, he forces the jittery crosshairs to latch onto the massive heat signature of the gun barrels. Raven 2's hands move with practiced precision across the upfront control keypad. He isn't aiming at the gunner, he is performing an offset Aimpoint strike. By slewing his shaky sensor onto the white-hot heat of the ZU-23, he tells his tactical computer, "That heat signature is my zero reference." He then inputs the mathematical shift, 120 meters north, bearing 000. The logic is cold and surgical. The computer uses the gunner's location to blind guide the bomb exactly onto the Il-76's spine. Pickle! Pickle! The 500-pound GBU 38 JDAM drops. It falls blind through the wall of Chinese GPS jamming, but its internal inertial navigation system has been perfectly synchronized with the offset Aimpoint coordinates. For 20 agonizing seconds, the bomb's tail fins twitch hundreds of times per second, fighting the mechanical drift to stay on the calculated path. The impact is a masterclass in structural finality. The bomb strikes the Il-76 directly behind the wing root. Before the chemical explosives even detonate, the sheer kinetic energy of the 500-pound steel casing tears through the thin aluminum fuselage, shredding the olive drab crates of guidance kits inside. A millisecond later, the warhead ignites. The high-pressure fuel being pumped by the APU for the engine start acts as an accelerant, turning the strategic asset of the IRGC into a towering funeral pyre. The gunner who provided the lighthouse is erased in the same shockwave. The Iranian calculus just met its match in American improvisational math. While Raven 2 completed his improvised offset strike, Raven 1 banked hard to begin the final cleanup mission. But Kerman Airport was not about to let the intruders leave without a cost. A lethal trap, built on the laws of thermodynamics, had been set across the rooftops of the airfield's maintenance buildings. As the Il-76 erupted into a massive fireball on the runway, Raven 1 separated from the formation to eliminate Iran's remaining 2 aviation treasures: the P-3F Orion maritime patrol aircraft and the C-130 Hercules transport. These airframes were over 50 years old, kept alive through half a century of extraordinary Iranian maintenance. Now, however, they were merely variables in a rapidly closing equation of destruction. The threat did not come from long-range missiles, but from a calculated ambush on the ground. IRGC units on the hangar roofs launched 2 MISAT, 2 infrared-guided MANPADS. They utilized a technique known as ripple fire, launching the 2 interceptors exactly 3 seconds apart. This was a classic energy depletion trap. The first missile wasn't meant to kill. It was meant to force Raven 1 into a high G brake that would bleed away his airspeed, leaving him as a low-energy target for the second interceptor. To survive, Raven 1 had to rewrite the laws of thermodynamics in mid-air. Against the first missile, he performed an immediate throttle back to cool the exhaust nozzles of his F-414 engines, simultaneously triggering a sequence of MJU-53 magnesium flares. Burning at 2,000 degrees Celsius, these flares created artificial suns on the missile's infrared seeker. The MISA-2's brain became overloaded by the intense thermal bloom and slammed into the decoys 100 meters behind the jet. However, the real danger was the second missile. With his energy depleted from the previous defensive turn, Raven 1 can no longer perform a high-speed brake. He is forced to rely on a high-stakes maneuver called tactical IR masking. He flips the Super Hornet inverted, placing the cold dorsal spine of the jet directly between his burning engine nozzles and the incoming interceptor. By physically shielding his primary heat signature, he robs the MISA-2 of its lock-on. The seeker head, suddenly deprived of its thermal target, goes dumb and streaks harmlessly into the empty sky. Having survived the missile trap, Raven 1 dove straight into the stream of tracers from the second ZU-23 twin-barreled anti-aircraft gun guarding the north apron. Instead of maneuvering erratically, he employed a structure masking tactic. He calculated his dive path so that the massive, reinforced concrete structure of the main hangar remained positioned directly between his jet and the Iranian gunner. The concrete blocked the gunner's vision for exactly 3 golden seconds, just enough time for the ballistic computer to finalize the coordinates and release the final 2 GBU-38 JDAM satellite-guided bombs. The resulting devastation was absolute. The P-3F and C-130 were torn apart as the 500-pound steel casings penetrated their fuel cells. 50 years of meticulous maintenance were erased in a 20-second flight time. Behind them, Kerman was a funeral pyre. The Il-76's auxiliary power unit, which was running during the initial strike, had become a high-pressure pump, feeding thousands of gallons of fuel into a firestorm that consumed the entire apron. Inside Raven 1's helmet, the victory is immediately eclipsed by the persistent, rhythmic chime of the master caution. On his left DDI, the fuel numbers are tumbling toward bingo, the critical threshold where he no longer has enough gas to get home. The intense 6G turns and prolonged afterburner use have exacted their price. The mission's calculus has shifted one last time, from a geometry of destruction to a geometry of survival. The KC-135 tanker orbiting over the Gulf of Oman was no longer a support asset. It was now the only variable keeping 2 American pilots from a cold grave in the Arabian Sea. If you want to continue following the strategic strikes of Operation Epic Fury, hit subscribe so you don't miss the next update. Goodbye.